Thank you, everybody. Thanks for seeing so many people who joined and will listen to my talk. So thanks for coming. I'll try to speak about data engineers and product development team, the goods, the bads, and as a colleague, as a lady was saying, all the neutral and other things that may be interesting. So. Without further ado, I'm going to talk about myself. So I'm Arūnas Vaitkus. I have around 15 years of data experience. Perhaps the more interesting part is that the time when I was making this presentation, I understood that, yeah, I'm getting old as well. It's not anymore young guy. So boomer jokes and dad jokes probably work for me too. I'm a father of a little girl. I've worked in multiple industries. So as you can see, I've worked in publishing, pharmaceutical, financial, agriculture, and automotive industries. A wide spectrum. Again, from data perspective, it's potentially similar. So those problems that you can see in different industries, they are repeat all over again. The usual roles that I was taking start from the knowledge engineering, data engineer, data architect, team leads, and at this moment I'm working as CDO at Car Vertical. Fancy name. I'm still interested in programming and writing some code, so it's depends. Still getting into the field, even though it's a little bit less of that. So leading a data department of around 24 people. Just perhaps the first question, I'm interested how many data department people are in here. Could you raise hands, please? That's quite a lot, so yeah, thank you. So I'll try to sell to your bosses, if there are your bosses in here, as well why data department and essentially specifically those teams are important to see in the product development team and perhaps interconnect the communication that is happening between the production product development teams and the data teams, specifically for data engineers. So. Introduction. So what we are going to talk about. So firstly, I'll start with the importance of a data in today's technology landscape. I'm pretty sure everybody knows about it. So just go through the basics and we will move further down. Typical data engineer, what does a typical data engineer do? And perhaps the next level is data engineers as integral members of product development teams. And later on, if it works or if it doesn't, or what kind of scenarios data engineering and data teams are not potentially helpful in the product development teams. So importance of the data in today's landscape, the current rate that we have around 300, or we are producing 330 exabytes of data per day. That's a big number. Let's say it's a big number. The easiest one probably to understand in the real life is around 330 million terabytes. So terabytes is easier. We have our machines. They are calculated in the terabytes. With the number of people we have in our human size population, that's around 40 terabytes. So every single of you are making around producing 40 terabytes of data per day. That's a lot. Obviously, the majority of the data is not, let's say, textual data that you type a message, you send a message to your friends, to your mother, to your wife, to your children. It's more around videos. So videos that you create, for example, on Facebook, on TikTok, that's the biggest number of the data. The size of data, again, in 2 years' time, it will be around 50% more. It depends. And it's that exponential number of the data that we are getting is important to think about it. Obviously, it's not only that we are going to produce more and we're going to type in the message tomorrow, more of the data, it's more around that hardware changes as well. So, you take a better video, take a bigger, better resolution photo and things like this. The other things that are around us and from technical perspective from your companies is potentially general analytics worlds that is around our work. So things like finance department perhaps is asking data. So that's again data that we are producing. Product analytics is another one that we are moving. So that's producing data too. Let's move on to talk about what does that typical data engineer do. It's quite a lot of things, but data engineer is a professional responsible for designing, constructing, managing the data itself. It depends from the company to the company. The bigger company, potentially those roles are getting specific to the needs. So perhaps the typical data engineer in the big enterprise is not going to do data modeling and architecture. Potentially you will have a separate team, a separate person who is going to be a data architect. But their work can still be in there. They can actually support your data architecture team with the specific questions. Data orchestration, data storage, again, can be the creation of it can be a DevOps team, but in smaller companies and startups, perhaps it's again a single person who is doing all of it. And documentation, obviously, nobody likes it, but it's part of every single developer's work. What I want to talk is perhaps, even though they do a lot, yeah, but perhaps they should do even more. I know it sounds terrible for, I guess, our data colleagues in here, but I think this may be the missing part to improve product development teams' efficiency. Even further what we have right now. So, for example, I believe that collaboration with a product team may be necessary. Okay, those data engineers and data teams can create and validate hypotheses with the product development team, bridge the gap between other teams that are belonging to data departments and the product teams themselves. Develop data products, be a part of a product development team, and essentially evolve beyond that typical data engineer team, and sitting in the middle of with one feet on the data department side and another feet on the product development side. So typical organizational structure looks like this. Obviously, I've taken out some other teams, some other departments. So we would focus on just the most important part. So there is a company, there's a tech department. Potentially, there's a product department as well, who are responsible to developing new products, new data products. And there's perhaps one person, perhaps multiple teams, departments. There are data engineering, data analytics, data science. Again, it depends on the company. It may be that data analytics and data science is the same department. And it's simple ones, typical teams will be back and front end, and a product owner if you have that. Now, the interesting part is typical data departments in the majority of companies are in a way working with directly with data analytics and data science teams, the teams that are producing the most interesting things and the last final artifacts that are important for the data products. And data engineers are those people who are building the middle part, the basics, right? That data analytics and data science teams can use. So, for example, data warehouse pipelines that would fit the data, push the data to data warehouse, perhaps prepare a new data lake, perhaps just to prepare data for the simple data set or an export for the finance team where they want to know all the customers' data, things like this. So again, as you can see in this diagram, data engineers potentially are working in a waterfall methodology, where they are just part of a next step. So giving their product, their artifact towards the other teams, data analytics and data science. I believe that the better structure, organizational structure, would be the discussion between data engineering, data analytics, and data science teams within their own limits, borders, and actually, instead of data analytics and data science talking directly to data product, data engineers will talk. Why? You may ask, why is that? Why is it better? Because it's upside down. It's reverse of what's usual. The reason for this is that typical data analyst or typical data scientist is more interested about prototyping, right? So their usual work is around prototyping a new model, doing research and development. And what is enabling them to show some sort of new ideas quickly. But to come up to that point, they may use the tools that are not good for the production itself, or the things that are good, for example, for backend. So, for example, who are doing some machine learning, scikit-learn, right? So it's usual things that you can use, usual framework that you can use to create a model. Yeah, it's totally fine to use on the production, but the idea is that perhaps there is the better tools that you can use, for example, more production ready for specific reasons like GBM framework or things like this. What is happening is that data engineers may have more understanding and be more central to the production ready environments, and thus creating the better systems that are connected towards the final data product. So what they're doing, they're creating more efficient ways of creating the needs that data product team is showing. I'll talk right now about multiple tools that you can use, and again, it's I think one of the teams that can enable that is data engineering, or in general, data teams, and that can be used and adopted in the product development teams. So one of them, again, it's this very simple diagram. I didn't want to go to the further detail. Yesterday was an amazing session from Swedbank. They were talking about similar things. So essentially, it's central repository for metadata, data catalog. Whereas multiple tools that you can use, multiple tools that you can use a managed service. So it's your choice what you want to do. Some cloud providers are doing it their own, but things is very simple. In essence, what it does, is getting the data about metadata about data or metadata. So perhaps you have a data lake, perhaps you have database, data warehouse, or semi-structured data, or any systems that your company is using. We're creating metadata. The data catalog can actually collect everything in a single place and then enable some interesting features. So, for example, enable search and retrieval of a data sets, easier things to understand what your company may have in the data and that product development teams may not know. Illustrate that data flow that you have, so lineage, for example. So there's a different lineage levels. So, for example, vertical lineage, where you can see the data transformations and, for example, different columns that you have, and you move from one side to another. When there is a value-based data lineage that is showing actually via graph where the data came from. So, for example, actual data came from. Again, that one is out of the question in this situation, but even column-based lineage is already enabling the product development teams to see some data that they perhaps missed or they didn't know about, and they can do it themselves. Next step, perhaps, would be talking to data engineers to get either sampling of the data or asking the actual data set what it looks like. So what it means is that instead of finding that information next to the coffee, product owners can do it themselves, at least at a high level. Obviously, there's things that it's enhancing data governance processes that you may have and compliance, but essentially, this kind of tool can empower product owners with comprehensive information about what they have in that data set or asset that your company owns. Again, it also helps with the things like data compliance. This is another thing, but it's not essentially creating help to the product owners. And obviously, it's also facilitating terminology. So another thing that I've seen so far is quite often data engineers or data department teams are using different terminology as any other products teams, front-end or back-end teams. So they call maybe database in one way or the specific asset in one way, but the data catalog can actually have synonyms and the same glossary that whole company can use and talk in the same language and finding the same data that they're interested in. Involving business in data governance is another perhaps contentious topic. So what we've seen, what helps to us is having product teams affecting those strategic solutions and decisions. So, for example, inviting our head of product development and data governance team seems as a beneficial thing because they know what the products and what end customers need. So essentially, having in the data governance, where data engineers and data architects are, they can create a better system and better data models that benefit product, getting them faster to time market, managing the data more often when otherwise, and understanding the needs themselves. There are so many times, and there's a disconnect between those teams because one lives in the data world, where there's a lot of things that to do for them with the data, and another lives in actually making product that is suitable for end customer. And obviously, it's building a trust as well. So product owners and the other teams are much more interested in a data if they are involved. Simple things like easily accessible data schema, and I mentioned documentation and glossaries help too. So even simple non-technical documentation, non-technical users with simple documentation can benefit from things like JSON schema. Again, it's very simple. It seems like it's not readable. There are tools that can make these schemas and documentations accessible to the team who is making product. Another thing, glossaries. As I mentioned before, terminology enables to teams talking the same lingo, and communication is one of those things where you can cut a lot of problems with efficiency in your company. Interesting tool to use is hypotheses. So how do they help? How do hypotheses can help you out? It's a great tool to fail fast. There's a lot of ways to look at the data and trying to create a data product. For example, you can create a product without even seeing a data or building something. That's totally fine. You can create it. You can discuss a lot in terms of first definition phase and things like this. But perhaps talking directly to data engineers and asking, hey, can you help us out with the hypothesizing if, for example, there is a data about the customer that owns a car, right? So do we have an ownership information? Yeah, okay, so we can do that hypothesis in a few days. And here we go. We know how big, firstly, we know how big that problem is. Second thing is we know straight away if it's feasible. And the third one is perhaps is done in your usual environment, or methodology or framework that you're using. So for example, Scrum, right? So perhaps it fits into your one sprint. And the next session can be actual subsequent sprints. Your data team already knows what the actual product owner wants. If it's successful, if it failed, it failed. Hey, you just used less than 1 week of your work. And it shows the scope of the feature, so how much work you have to do. This is interesting. There's knowledge sharing sessions too. This is interesting if your company is having multiple products. So from time to time, every single product thinks that they are unique, right? So every single product wants to be unique. But if you are in data company or data products company, you'll quite often see that products need have the same basic needs, right? So they need to know about customers, so that's usual analytical marketing needs. But then they have humans doing most of the times the same, have the same behavior, right? So even the product is different, maybe it's segmented differently for different audience. Perhaps you'll find some things that are similar. And that's the interesting part. If you involve the data team, they probably had the same feature that other product team and other product asked. So by knowledge sharing sessions, you may find that another product will also want the same tools and the same data products that your team, your data engineers have developed. And it's usually the biggest benefit is that data or that product is already ready and accessible because it was used by somebody else. I want to talk about, so at this moment I'll just talk about cows, I guess. I'll start with cows. For me, this is, again, my experience about different teams and different structures that worked, and perhaps some of them that could be implemented better or work slightly better. So one of them is agricultural analytics company, which was working on analytical data to help farmers with understanding, for example, cattle, how much cows can produce milk, what do they need to eat. So a highly technical company that's using satellite imagery to understand if, for example, how much hay they will produce from the grass and if the cows are healthy and things like this. The interesting part, that project, that part of the company were fine. The interesting part was in the data side and the actual product development side. There was a disconnect between the data department, data engineers, and the product team. What was happening is that the data team was building their own complicated siloed data warehouse, guessing what is necessary, and at the same time creating a really simple, let's say, back-endy APIs that were necessary for a product without consulting the product owners. Again, they were doing the best job, so they were actually assuming what was necessary for the end product and trying to get to the point and understanding, even though they could ask the questions that the product needs, it was difficult. So, you know, just because of everybody's busy with their own work, and it's normal, it's natural. Backend developers at some point got frustrated and then built their own system. What in the end happened is that startup was unfortunately not as successful as could have happened. So what could change in here? So perhaps we could have more discussions between different teams and have the conversation. Does our data warehouse work? Do we need to build data warehouse at this moment? Maybe it's too early. Perhaps let's talk it. Maybe use hypothesis if this works and things like this. Our was a publishing company that is also interesting. This is getting better. It was still building siloed data that took time to get it to reality. The interesting part was having a massive enterprise architecture team happening in the different continents. And it was very strong data architects. The interesting part is, since it's very strong architectural roots that company was having, the schemas were taking way too long to build. So imagine you build a schema for a month or two, and you have conversations about do we use semicolon or colon? Yeah, it's important. I know it's important. I know it's important for data architecture, but the interesting final point is that even data transformations were taking too long. You can't fit into the usual product development team of if you need to build an epic every single time and you want to do a schema. And the idea is that, again, it's development. The product teams were having trouble to build their products quickly because the data team was moving slow. So no tasks was fitting to 2-week cycle. More interesting, as usual, is investment banking companies. So financial services in general. So usual thing that data engineers are doing is building data products after financial crisis for the banks. So in this case, we had a bank that was having around 50 data engineers who are working in multiple Scrum teams, so 8, 9 separate teams working on different reports for the whole world, financial authorities, organizations. What was working in here, even the scaling was much bigger than usual startups, is that data engineers were involved with the key decision makers. So we were talking to directors of that bank, and they were discussing what kind of structure is actually helpful for the end product. So for financial authorities, for themselves in the front office and the people who are making decisions in the bank. And what's interesting is that the final solution for this was much better when you think about stereotypical financial institution that is subject to a slower change due to a lot of different regulations that we have. And the last one is I'll talk to what we have right now. So this is what's interesting because we started our company 5-6 years ago, and we could actually, adopt some things that we thought are better, right? So bring those ideas and perhaps look at, small company, easier to integrate product teams. So we tried to do what I was talking before. So bringing data engineers into the product team directly, having the backend engineers, having front-end engineers, and the product owner that's bringing everybody together. And it's interesting. So what we have seen is that data engineers consulting directly to the product owner helped in other products that we are building. So we could, data engineers were happy. So data product was happy because their voice was heard. And since we were heard at the same time, we were interested to making that whole product more interested. So what you're getting is essentially the enablement of data teams to produce something better. And at the same time, reducing that time to market of the products. Hypothesis, again, is just a simple thing. Maybe it's the conversation or part of the your sprint, which helps to data engineers to produce something that product needs and fail fast. Tasks, again, so far so good. Obviously, there's different corner cases and things, but most of the times fit into our agile lifecycle limits. Obviously, it's not always easy path that you have. It also there's a limitation. So one of them is data engineers are interested about the data, right? So they are explorers. They sometimes explore too far away and goes from the main objective that they need to do. Again, it's usual thing of the focus. They may need more and different set of skills. So what I mean by that is data engineer anyways has a lot of skills that is necessary for now running the modern data stack. We're asking them to discuss with the product teams. They need additional, perhaps soft skills or perhaps documentation skills that they may not have. So by having this, there is a con that it's more difficult to hire these kind of people. Sometimes we are distracted by work that's related to the data needs or technical data that data department has created. For example, migrations, right? So, and from time to time, you need to move from single database maybe to the cluster. Maybe you want to move from Postgres to Snowflake for, I don't know, you create a new data warehouse. Again, it requires a lot of work or migrations, or you just change the schema. Again, you need data engineers working on it. So they may not be available all the time when you need, but that's one of the minus. Some of the data teams may feel left out. Again, it depends on the culture of the company. This can be solved by introducing those, work together for data science and data analysts and data engineers together in product team. Again, depends on the company how we want to work with the morale of the data departments. But if these things are kept in mind, long-term benefits are pretty good. I would say that you can see the data ecosystem that such structure brings is enabling other products that your companies can create faster. So data engineers know what one product needs. If they talk, perhaps they sell the same product to another product, the same idea to another product. And what's happening is that there's only a single idea that we have less things to monitor, less things to code, less things to maintain. Product teams as well, product owners seem are getting more involved in the data. they are interested, they are actually checking the data and asking the questions that sometimes your data departments may just miss because they didn't think about it. Obviously, happier customers is always nice to hear when you hear, perhaps not directly, but through our teams that a customer says thanks for specific data product that those data engineer teams have built, and less pressure and unnecessary communication between different teams, especially data teams. So key takeaways. Try to integrate your data engineers and the product teams. Listen to what your data engineers and in general what your data team people may say about how to improve your products. By listening, they can actually come up with interesting ideas and help to your data engineers to understand what those product needs are. Because if they understand, they may again produce something that nobody thought about because they are working with the data every single day. And collaboration in general just brings, I think, best of both worlds all the time. That's it. Maybe there's some questions. Thank you. Thank you. Thank you. Okay, so in the current company that we are working, we actually have machine learning engineers, and they fit in. I just call data science team, so it's a more generic term again. That's as I was talking about data catalog, a terminology that everybody understands. Machine learning, and at least in our company, team is responsible for creating models, and the most importantly, creating models that are product ready and production ready. So what I mean by that, there is a model that you can build quite easily, right? It's going to support your needs, but again, data is shifting. So perhaps after 1 year or 2 years, it's not going to work. A good example of from Car Vertical. So we built a system that detects damage from photos, right? So again, yeah, it works. Data science would do a great job. Hey, let's shake hands and let's go on further. The typical problem happened. New photos we were getting from our data providers were coming with the snow. Another season came in and just kind of destroyed our solution just because we didn't train the model with the cars that have a snow, and that's the problem. So again, it's machine learning engineers would help you to build the really the production ready system and focus on that part of it, which is actually productionizing the systems instead of building a model and saying, this is a research part. This is somebody else's, responsibility right now. Yeah, I can. Within 2 weeks, and in general, how let's say, okay, so it depends. So I guess since this was started, it was easier to come up with the latest and greatest data and things that we've seen from historical and previous experience. So we built a lot of automation. So the documentation is part of our, let's say, data structures. But majority of it, the way it works, for example, every single time the data team is pushing the new data structure, there are tools that can automatically create documentation by running your systems like GitHub Actions, right? So you can use readily available tools that automatically create documentation. Okay, it takes time. It takes perhaps 1 week of time, but again, it depends on the company. If company allows to some time for data teams to build the tools that may not be beneficial for a month or a year, it will be beneficial over a longer period of time. Whereas, for example, right now we have a documentation, but we don't do anything. we don't write our own documentation. It's part of a code. Yeah, there is a process that does it, but majority of tools that we're using just do it automatically and brings everything to, let's say, a developer portal that we have, and never can be shared. So it depends. So data catalog can help as well, as I mentioned. We have a dedicated team that is running a metadata and bringing the last bits of documentation that we can't automate. So for example, usual things is data warehouse, right? So it's possible to automate some things from the cloud providers. They have their own data catalogs. Maybe user interface is not going to be brilliant, but it's possible to, again, collect that data from the data catalog and maybe use managed data catalog. DBT is making amazing lineage and bringing amazing documentation if it's part of your processes that you are using. Perhaps right now GDPR, for example, for Europe is important. Again, you can easily automate by asking data engineers to bring perhaps their feeling that there is personal identifying information and bring by automatic way saying that hey, if you have a DPO, hey, can you check it if it's actually reality or if it's not true what that person, the developer, was working in your data, because maybe it's not true, maybe it is. Not everybody, is able to know all the jurisdictions that are happening in Europe. So it depends on the. What I'm trying to say is that it's possible to automate a lot of things, and if the company leadership is allowing that, I think it's very beneficial over a longer period of time.